You know that feeling, right? You're running some complex analytics, maybe loading a huge data set, and then bam, everything it just chokes. You're staring at a frozen screen or maybe that little spinning wheel of doom.
Oh, yeah. That frustration is real.
Well, often the problem, the real bottleneck,
Yeah.
it's hiding beneath the surface. It's about how your data is stored and, crucially, retrieved.
Exactly.
So today we're doing a deep dive into storage testing. Our mission, really, is to unpack what that actually means. Why it's honestly kind of make or break for application reliability.
It really is.
The different ways you go about doing it, and, this is important, some common slip-ups to watch out for.
Yeah, pitfalls are easy to fall into.
And we're drawing all this from some pretty solid sources like Storage Testing Essentials.
Good stuff in there.
Okay, so let's get down to brass tacks. What is storage testing?
Well, put simply, it's a kind of software testing, right?
Right.
Its job is checking if an application stores its data correctly in the right place.
Okay.
And, importantly, if there's enough space, so it doesn't crash just because the disk is full.
The out-of-disk space nightmare.
Exactly. You'll often hear it called storage performance testing, too, because performance is a huge part of it.
Makes sense.
And what's often maybe underestimated is how directly poor storage performance hits you, the user.
How so?
Well, we're talking sluggish apps, queries that seem to take forever.
Yeah.
Sometimes the application just isn't available at all. And behind the scenes for the companies running this stuff, it's a massive overhead maintaining all that server infrastructure.
Right. It costs real money. And I guess the proactive value here is huge.
Immense. You get to find those practical storage limits before you deploy.
Before users start complaining.
Precisely. Prevents major headaches. Plus, it gives you a clear idea of how things will handle hardware changes, upgrades.
Like future-proofing.
Exactly that.
Yep.
Super important.
Okay, so how is this actually done? Our sources mention three main ways: application testing, application simulation, and benchmarking. What does that look like practically?
Okay, let's break those down. For application testing, think about comparing real-world stuff.
Yeah.
Like how quickly does your online transaction system respond? OLTP response times. Or how long do those big overnight batch jobs take?
So testing actual workflows.
Exactly. Validating performance with the real application doing its thing.
Gotcha. What about application simulation then?
That's more about pushing the limits under controlled conditions. You might test peak storage IOPS.
IOPS.
Input-output operations per second. Basically, how many read-write requests the storage can handle. Crucial for demanding databases.
Okay.
Or you might test the maximum throughput for, say, data streaming, how much data can flow through per second.
Right.
And it also involves measuring storage latency, that tiny delay between asking for data and getting the first bit back. Super critical for things like messaging apps.
Yeah, needs to be instant.
Pretty much. Then the third one is benchmarking.
Okay.
This uses standardized tools to test general storage capabilities. But here's a really critical aspect people sometimes miss.
What's that?
Testing specifically for data corruption.
Oh, wow. Yeah, not just speed.
Not just speed. Think about it. One flipped bit in a financial record or a medical file. The consequences can be, well, catastrophic. It's about data integrity.
That's a really crucial point. Integrity over just raw speed sometimes.
Absolutely.
But, even focusing on the right things, it seems easy to mess this up. The sources mentioned common mistakes, even for experts.
Oh, definitely. It happens. One classic mistake is monitoring the wrong server metric.
Like looking at the wrong dial.
Kind of. You might be watching CPU usage like a hawk, but the real problem, the bottleneck, is the disk I/O. The system's just waiting for the storage.
So you're optimizing the wrong thing.
Exactly. Another big one, forgetting to clear the server cache before comparing storage devices.
The cache. The temporary fast storage.
Right. If you don't clear it, you're testing how fast data comes from that speedy cache, not the actual storage device itself. Skews your results completely.
I see. Sneaky.
Very. Also, people sometimes forget to watch the processor during the test. If your CPU is maxed out, it'll make your storage look slower than it is.
Another misleading result.
Yep. And maybe the most counterintuitive, trying to gauge serious performance using just simple file copy commands.
Like just copying a big file. Why is that bad?
Because it's too simple. It's like testing a Formula One car by driving it to the shops. Real applications hit storage with complex, unpredictable patterns. Simple copies don't reflect that at all.
Okay, that makes sense. Leads to a false sense of security.
Totally. Or just plain wrong data.
So let's bring this back to you, the listener. Understanding this stuff. storage testing, it basically means the apps you rely on every day. They're more likely to store your data correctly, have the space they need, and just run smoothly. It's kind of the invisible engineering stopping those annoying slowdowns and crashes.
It really is the hidden foundation for a smooth digital experience.
Yeah, makes your digital life, work.
Which actually raises an interesting question, doesn't it? When you think about all this hidden complexity, this performance engineering behind every click, every save,
Yeah.
how does knowing this change how you see the digital world around you? And maybe what other invisible systems do you think are just as crucial to our daily tech lives, but we never really notice them?